Today's topic is trigonometric identities. As we know, this trigonometry is completely based on a right angle triangle, and we know this any triangle will be having three sides, so three vertices. So we'll name those three vertices. And I said this trigonometry deals with a right angle triangle, including two acute angles, and these three sides of triangle will be having various names. So this is called as in base, and the longest side is called as in hypotenuse, and the line which is making an angle 90 degree, always we know the line which makes an angle 90 degree is a perpendicular, so we'll call this line as perpendicular line. So here we'll be having three sides, three vertices with one 90-degree angle and two acute angles. The three sides are base, hypotenuse and the perpendicular. And in this chapter we are going to use identities to solve various types of simple algebraic trigonometric expressions. And here we'll be using trigonometrical ratios, which are also called as in T ratios. T ratios are nothing but trigonometrical ratios. Here we'll be having 6 types of trigonometric ratios. They are, first we'll be having sine, and here angle is A. So sine A will call our trigonometric functions with an angle, whatever the angle is, maybe the vertex. We'll use that vertex of an angle and we'll be naming those ratios as sine A. So from first sine A, the value of this sine A is the side perpendicular by the longest side hypotenuse. Perpendicular by hypotenuse. This perpendicular can be written as BC and this hypotenuse can be written as AC. This is our first ratio, and the second one we have is cosine. Cosine is also called as in cos, and the value of this cos based on sides are base by hypotenuse, and the base side is AB and the hypotenuse is AC. So, and the third one we have is tangent, which is also called as in tan. Simply we can call it as in tan, and the value of this tangent is perpendicular by base side. Perpendicular by base, and the perpendicular side is BC and base side is AB. And after this tangent we'll be having cot. The value of this cot is base by perpendicular. Base by perpendicular. So what is the value of base, which is AB, and perpendicular side is BC, and fifth side is secant A, which is the value of the secant A is hypotenuse by base. Hypotenuse by base, which is hypotenuse is AC and the base is AB. And the last sixth trigonometric ratio we have is cosecant. Cosecant A can be written as hypotenuse by perpendicular. So our hypotenuse value is AC and our perpendicular value is BC. If we observe here we have BC by AC, and whereas here we have AC by BC. Just inverse of sine, just the sine and cosecant are of inverse to each other. That is, sine A can be written as 1 by cosecant A, which can be written as, cosecant can also be written as 1 by sine A. Here we have BC by AC, and whereas here we have BC by AB. Both are inverse to each other. So thus sine can be written as 1 by cosecant, whereas cosecant can be written as 1 by sine. Similarly with cosine and secant, here we have AB by AC and here it is AC by AB. Here cosine and secant are inverse to each other. So here also we can write cos A by 1 by secant A. Similarly, secant A can be written as 1 by cos A. So sine, cosecant, cosine and secant are inverse to each other. Next, BC by AB we have, AB by BC we have. Here both are inverse to each other. So here we can write tan A is equals to 1 by cot A. Similarly, cot A is equals to 1 by tan A. So these are some relations between the C ratios. Sine, cosine are inverse to each other. Sine and cosecant are inverse to each other. Cosine and secant are inverse to each other. And tangent and cot are inverse to each other. So these are some relations. And we have some more relations regarding this. So some more relations are, we have sine A is equals to BC by AC, and we have cos A is equals to AB by AC. Let's divide sine by cos. Sine A by cos A. What is the value of sine A by cos A, which is BC by AC into AC by AB. So when we simplify this, we'll get our sine A by cos A as BC by AC. So BC by AB is nothing but tan, right? So here we can write sine A by cos A is equals to tan. So this is one more relation we'll be having. This is called as in quotient relations. So the second one in this quotient relations are sin. So instead of sine by cos, let's do cos by sine. Cos by sine. So cos by sine is AB by AC into AC by BC. So which is AB by BC. AB by BC is nothing but cot. This is our second relation in quotient relationships. Next we will be having third relation, which is tan A into cot A is equals to 1. What is the value of our tan, which is BC by AB? And our cot value is AB by BC. When we simplify this, we'll get our value as 1. That is, the product of tan and cot gives answer as 1. These are the three quotient relations we'll be having. One is sine by cos is equals to tan, and the second one cos by sine is equals to cot, and the product of tan and cot is equals to 1. Next relations we have is square relations. So first one from the square relations is sine square A plus cos square A, which gives us answer as 1. Let's simplify this. What is the value of sine square A? BC square by AC square. Next, cos square A is AB square by AC square. So here we'll get BC square plus AB square by AC square. Whereas our BC and AB are perpendicular and base. Perpendicular square plus base square is equals to hypotenuse from our Pythagoras theorem. So we can write it as AC square, and the denominator remains same, which is AC square. So when we simplify this, we'll get our value as 1. So from this, we'll be having sine square A plus cos square A is equals to 1. So this is our first square relations. Next we have 1 plus tan square A, which is 1 plus tan square A is BC square by AB square. This will write it as AB square plus BC square by AB square. Again, same, AB square plus BC square is nothing but AC square. AC square by AB. What is our AC by AB, which is secant? So this can be written as secant square A. So our relation 1 plus tan square A is equals to secant square A. This is our third relation. Next we will be having 1 plus cot square A, which is 1 plus cot is AB square by BC square. Thus we can write it as BC square plus AB square by BC square. Again, BC square plus AB square is nothing but AC square. AC square by BC. AC by BC is cosecant square. So third relation is 1 plus cot square A is equals to cosecant square A. These three are also called as in trigonometric identities. These three are also called as in trigonometric identities. In any case, this gives us the same relation. These are the three trigonometric identities. These are the basic concepts to solve this exercise. Now let's go with our exercise 22A. From that we have our question number cosecant A plus 1 by cosecant A minus 1 is equals to 1 plus sin A by 1 minus sin A. So here we need to prove LHS is equals to RHS. Either we can simplify this LHS to get the RHS, or else we can simplify this RHS to get our LHS. Let's go with our LHS. Here we have cosecant A plus 1 by cosecant A minus 1. And as we know, this cosecant can be written as 1 by sin A. So 1 by sin A plus 1 by 1 by sin A minus 1. So here we'll be taking the LCM. We'll get 1 plus sin A by sin A whole divided by 1 minus sin A by sin A. So the sin and sin gets cancelled. We'll be having 1 plus sin A by 1 minus sin A, which is nothing our RHS value. Therefore, our LHS is equals to RHS. This is our question number 1. So this is our question number 2. Same like the first question. We'll take LHS value to get RHS. This secant can be written as 1 by cos. Convert this secant into cosecant. So we'll be getting 1 by cos A minus 1 by cos A plus 1. Next, we need to take the LCM. LCM is always equals to cos A. 1 minus cos A by cos A and whole divided by 1 plus cos A by cos A. This cos and cos gets cancelled, and remaining answer is 1 minus cos A by 1 plus cos A, which is our RHS value. Therefore, LHS is equals to RHS. So next we have question number 3. So whenever you are having any kind of question, first try to simplify it as much as possible. Don't try to expand it. So here we have sine. So this will have to sine and cos we have. Let's convert this tan into sine. So here we'll be having sine A into. As we know, the sine can be written as sine A by cos A and whole divided by 1 minus cos A. So sine into sine is sine square A by cos A. So this will be having 1 by 1 minus cos A. And we have an identity, right? Sine square A is equals to 1 minus cos square A. So I'll replace the sine square with 1 minus cos square. 1 minus cos square A by cos A into 1 minus cos A. If we observe, this is in the form of A square minus B square, which can be written as A plus B into A minus B. When we multiply, again we'll get the same answer. So let's expand this. 1 minus cos A by 1 plus cos A by cos A into 1 minus cos A. This numerator terms 1 minus cos A, 1 minus cos A gets cancelled. Here we have 1 plus cos A by cos A. Let's divide this numerator terms. We'll get 1 by cos A plus cos A by cos. 1 by cos is nothing but secant A. This cos and cos gets cancelled, which is equals to 1. This is our RHS value. Therefore, LHS is equals to RHS. Question number 4, we have 1 by tan A plus cot A is equals to cos A into sin A. So we need to get our answer in terms of cos and sin. So convert this tan and cot in terms of cos and sin. So we know this tan can be written as sin A by cos A. Similarly, this cot can be written as cos A by sin A. Now let's simplify this denominator. We'll take the LCM. LCM will be equals to cos A into sin A. So this we have to multiply with sin. So we'll get sin square A. And this term we have to multiply with cos. So we'll get cos square A by cos A into sin A. Let's transpose this. We'll get cos A into sin A by sin square A plus cos square A. And we know our square and we know our identities. So sin square A plus cos square A is equals to 1. So we'll be getting our answer as cos A into sin A, which is our RHS value. Therefore, LHS is equals to RHS. Next we have 1 plus tan A whole square plus 1 minus tan A whole square. If we observe, it is in the form of A plus B whole square plus A minus B whole square, which is nothing but 2 times of A square plus B square. Now let's simplify this. We'll get 2 times of A square is 1 square and B square is tan square, which is equals to 2 times of 1 plus tan square A. And we have a relation to 1 plus tan square A is secant square A. That is 2 into secant square A. What if you don't know this condition? So just try to expand this in the form of A plus B whole square and A minus B whole square. A plus B whole square is A square plus B square plus 2AB. And next, this is A minus B whole square, which is A square plus B square minus 2AB. Plus 2 tan A minus 2 tan A gets cancelled. 1 plus 1 is 2 and tan square plus tan square is 2 tan square A. From these two terms you can take off 2 as a common term. We'll get 1 plus tan square A. And same condition, 1 plus tan square is secant square A. This is our RHS required value. Therefore, LHS is equals to RHS. Next we have our question number 6, which is sin square theta minus 1. This theta is nothing but an angle. Instead of A, we can write this symbol which is called as in theta. So sin square A, sin square theta minus 1 into tan square theta plus 1, and plus 1 is equal to 0. This is what we need to prove, and here we'll be using some identities. Clearly we have sin square theta plus cos square theta is equals to 1. From this we can write sin square theta minus 1 is equals to minus cos square theta. This is our first we'll be using. And next we have 1 plus tan square theta is equals to secant square theta. So I'll replace these two with these two conditions. In place of sin square theta minus 1, I'll write minus cos square theta. And in the place of 1 plus tan square, we can write secant square theta. And this plus 1 remains same. And as we know, the secant is inverse of cos. The secant can be written as 1 by cos. So we'll write the secant square theta as 1 by cos square theta plus 1. This cos square and cos square gets cancelled. Minus 1 plus 1 is equal to 0. This is our RHS we need to prove. Therefore, LHS is equals to RHS. So next we have our question number 7, which are in the form of cosecant, cot, and cos. So try to get all the terms in one or two trigonometric functions. So first I'll replace this cosecant A with 1 by sin A. This we know, and I'll leave this 1 plus cos A as it is. And this cosecant can be written as 1 by sin A, and this cot can be written as cos A by sin A. Right. Next, write this 1 plus cos A by sin A as it is. And here we'll be having same denominator. We can write 1 by this cos A by sin A. Now we'll just multiply these two terms. It is in the form of A plus B into A minus B, which is A plus B into A minus B is A square minus B square. So this can be written as 1 minus cos square A, and sin into sin is as usual sin square A. And we have our identities. 1 minus cos square A can be written as sin square A. So I'll replace this numerator with sin square A by sin square A. Both the values get cancelled, which is equals to 1. Our required RHS value. Therefore, LHS is equals to RHS. So this also get it in one or two terms. So try to get this in sine and cos form. This secant can be written as 1 by cos A. Leave this 1 minus sin A as it is. And the secant can be written as 1 by cos. And this tan can be written as sin A by cos A. Again, this I'll write it as 1 minus sin A by cos A. And here we'll be writing with LCM 1 plus sin A by cos A. Again multiply this in the form of A minus B into A plus B, which is A square minus B square, and cos into cos is cos square A. And as we know, 1 minus sin square A can be written as cos square A from our relations. So I'll replace this numerator with cos square A, and the denominator remains same, which is equals to 1. This is our required RHS value. Therefore, LHS is equals to RHS. So here we have three different terms, and we know this sine and cosecant are inverse to each other, secant and cos are inverse to each other, and tan or cot are inverse to each other. So simplify each term separately, then we'll go with our next procedure. Thus cosecant can be written as 1 by sine. 1 by sine theta minus sine theta, leave as it is, and this I'll write it as 1 by cos theta, and from this you can change any one of this. So we'll get sin theta by cos theta plus cos theta by sin theta. So here we can write it as 1 minus sin square theta by sin theta, because here we'll be taking the LCM, so we'll get 1 minus sin square theta, and here we'll get 1 minus cos square theta by cos theta, into here also we'll take the LCM, we'll get sin square theta plus cos square theta by cos into sin. And again just multiply these terms or simplify this. Here we have 1 minus sin square theta from our identities, only one identity. Here we'll be having as of now sin square theta plus cos square theta is equals to 1. So 1 minus sin square can be written as cos square by sin A remains, sin theta remains same, and 1 minus cos square can be written as sin square theta, and cos theta remains same here, and here sin square theta plus cos square theta is equals to 1 by cos theta into sin theta, and for this square and one cos gets cancelled, square and one sin gets cancelled. Here we have cos theta into sin theta, which is multiplied by 1 by cos theta into sin theta. So both the numerator and denominator values get cancelled, and our remaining answer will be equals to 1. Therefore, LHS is equals to RHS. Next we have our question number 10, which is cosecant A plus sin A into cosecant A minus sin A. So here it is in the form of A plus B into A minus B, and we need to get cot square A plus cos square A. So whenever you are having like this, try to use identities. We'll be having use of two identities, which is, as we know, sin square A can be written as 1 minus cos square A, and cosecant square can be written as 1 plus cot square A. So we'll use these two identities here. First, it is in the form of A plus B into A minus B, which can be written as A square minus B square. That is cosecant square A minus sin square A. Replace this cosecant square A with 1 plus cot square A. So here I'll write 1 plus cot square A minus sin square A can be written as 1 minus cos square A. Now simplify this, we'll get 1 plus cot square A minus 1 minus of minus plus cos square A. This plus 1 minus 1 gets cancelled. Now here we are remaining with cot square A plus cos square A, which is our RHS value. Therefore, LHS is equals to RHS. So here also in question number 11 also we'll be having square terms. So here also we'll be using square relations here. First let's simplify this LHS, which is in the form of A plus B into A minus B. So here we can write it as A square minus B square, which is secant square A minus cos square A. So let's use an identities, and we know 1 plus tan square A is equals to secant square A, and 1 minus sin square A is equals to cos square A. Use these two identities, replace the secant square with 1 plus tan square A, and thus replace this cos square with 1 minus sin square A. Now simplify the terms. 1 plus tan square A and minus 1, minus of minus, plus sin square A. This plus 1 minus 1 gets cancelled. We'll be having tan square A plus sin square A, which is our required RHS. Therefore, LHS is equals to RHS. So here also take the LHS value in question number 12, which is tan square A minus sin square A. Replace this tan with sin and cos. So this tan square can be written as sin square A by cos square A minus sin square A. From these two terms, we can take out sin square A as common. So if we take out sin square A as common, we'll get 1 by cos square A minus 1. Now simplify the terms which are inside the bracket by taking the LCM. We'll get sin square A, and here 1 minus cos square A will get 1 minus cos square A by cos square A, and we know this 1 minus cos square is nothing but sin square A by cos square A, and we know sin by cos is nothing but tan. So this replace these terms with tan square A, which is nothing but our required RHS value. Therefore, conclude our answer with LHS is equals to RHS statement. So this question is also saying like the previous one, replace this cos with cos and sin. So we'll be writing this as cos square A by sin square A minus cos square A. So here I'll take out cos square A as common. We'll get 1 by sin square A minus 1. So again, take the LCM here, we'll get 1 minus sin square A by sin square A. From our identities, 1 minus sin square A is nothing but cos square A. Cos square A by sin square A. And same, this cos by sin can also be written as cot. So we'll get cos square A into cot square A, which is our required RHS value. Therefore, LHS is equals to RHS. So here we know that the secant and cosecant will not have any kind of relation. So convert these two values into another form. This secant can be written as 1 by cos square A, and this cosecant can be written as 1 by sin square A. Now go with our LCM procedure. We'll get sin square A plus cos square A by cos square A into sin square A, and we know our identity, which is sin square A plus cos square A is equals to 1. We'll get 1 by cos square A into sin square A. Now divide this into two terms. We'll get 1 by cos square A into 1 by sin square A, and we know 1 by cos is nothing but secant square, and 1 by sin square is nothing but cosecant square, which is our required RHS. Therefore, LHS is equals to RHS. Next we have question number 15, which is tan square A plus cot square A plus 2. If we observe this, this is in the form of a square plus b square plus 2ab. And we know that tan A into cot A is equals to 1. Right? So tan A plus cot A whole square is nothing but tan square A plus cot square A plus 2 tan A into cot A. So now this LHS, we can write it as tan A. This LHS, we will be writing it as tan A plus cot A whole square. Now convert this in terms of sin and cos. This tan can be written as sin A by cos A, and this cot can be written as cos A by sin A. Now we'll go with our LCM. We'll get sin square A plus cos square A by cos A into sin A, and don't forget to write the whole square part, And we know our identity, which is sin square A plus cos square A is equals to 1. So now the numerator will convert into 1. We'll be having 1 by cos A into sin A whole square. To write this into two different terms, we'll get 1 by cos square A into 1 by sin square A. And as we know, 1 by cos can be written as secant square A and 1 by sin square can be written as cosecant square A.